Okay, so we've been working a lot with data and different ways to display them between scatter plots and two-way tables, but not all data displays are accurate. And actually, a lot of data displays you'll even see in the media can be misleading. So we're going to talk about some things to look for in misleading graphs today. So your title is Data Displays, and this is the first graph you want to cut and paste into your notes. And we are trying to record the number of hits for your school's new website over 5 months, and we're going to tell whether each data display is appropriate for representing how the number of hits changed during the 5 months. All right, so this first one is a bar graph, and it is appropriate. So I want you to write what I'm typing right now. Yes, because there is one bar for each month, and each bar is the same width. Okay, that's something important to look for when you're looking at misleading bar graphs. Sometimes they'll make one wider to make it look bigger when really it's the same height as another one. Okay, the next one we want to look at is this frequency table. So this part at the top is still the same as before. We're looking at number of clicks on our school website over 5 months, and this is no, it's not appropriate because the data is not organized by month. Okay, if our big thing we want to know is how it changed over that 5-month time span, then we need months on here instead of just number of hits and frequency. Okay, this one, same situation. Is it appropriate or not? So a line graph, the big thing you want to look for is that your scale is the same. So between each month, looks like we have 2 grids. So since all of our distances, they're the same amount apart, then we can say yes. Data is organized by month. Months are evenly spaced apart. So those 2 graphs are all for the same situation. So you can organize data in a lot of ways, but you have to know what data is appropriate or what representation is appropriate. Okay, so next we're going to look at comparing 2 graphs and which one is misleading and which one is not. Okay, which line graph is misleading and explain. So when we're talking about graphs, you really want to pay attention to scale. So let's go ahead and add a hint here. Check scale, check width. Those are the 2 things I would check first, right off the bat. So when we look at our scale, this one goes 9, 10, 11. This one goes 2, 4, 6, 8, 10. And along the bottom, it looks like they're exactly the same. So we're actually going to say that this graph on the left is misleading. And that is because the scale goes from 0 to 9 and then counts by 1. The second graph counts by 2. Okay, so this is more accurate looking. And then this one, this looks like it goes down and up a lot, but really it's only going down and up a little bit up here, all in the neighborhood of 10. Okay, but it doesn't look like that when you jump from 0 to 9. Okay, another example. Again, you want to look at scale and you want to look at width first thing. So here my scale 5, 10, 15, 20, 25 is the same on both. And along the bottom it's the same also. But if you look, these are all the same width. But here, as you go, they get wider, which makes these look number 5 looks way bigger than 1, when in reality, it's not that much taller. It's maybe only 2 different units taller. So we're going to say this time that it's this graph on the right because the bars are different widths. That's why it's misleading. Okay, and news will do this, companies will do this to try to make the data show what they want. So keep that kind of thing in mind when you watch the news or you're looking at stats of any kind. People can manipulate how the graph looks to make it look different than it really is. So these are good skills to have. For this last one, it says the organizer of a food drive creates the pictograph shown. So this one, which you're going to cut and paste into your notes. Part A, a volunteer concludes that the number of cans of food and boxes of food donated were about the same. Determine whether this conclusion was accurate. So, canned food and boxed food. The volunteer probably concluded they're the same because they're pretty close to the same length. However, if we count these cans, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And box food would be 1, 2, 3, 4, 5, 6. So this is actually not accurate. So if each can is worth 20 and then there's 5 extra, there are 100 more cans than boxes. Then it says, estimate the number of each item that has been donated. So for cans, if we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 times 20 is 220 cans. For boxes, we have 1, 2, 3, 4, 5, 6. 6 times 20 is 120 boxes. And for juice, we have 2.5. So 2.5 times 20 would be 50 bottles of juice. Okay, so now when you have it multiplied out like this, you can easily see that there are 100 more cans than boxes. So pictures can be misleading because these boxes of cereal are wider than the cans they used for the picture. Okay, raise your hand and I will give you your homework assignment.